Okay, we are continuing with our point class and client. We have set up the constructors. We have two, one for input of X and Y parameters, the other with the default setting up the origin and this use of the keyword this in both those constructors. The first one referencing the fields of the object or class, and the second one referencing the first constructor, calling the constructor with two parameters, 0 and 0. Okay, so now we'll do our setters. So setters allow a program to change the values of X and Y. So we'll go public, no static. It's going to be void. It's not returning anything. It's going to be called setX. And it's going to have a parameter of X again, because it's going to change the X value. So then what are we changing? We're changing the X value in the field. So I want to then reference this again, this dot X equals X. Seems a little bit weird, but think about this X as coming in as a parameter. Well, I shouldn't maybe not use the word this here. The X in the actual parameter is coming into the function, and you can see that that's highlighting this guy, the one below it, whereas this dot X, when you highlight it, is highlighting the X up here as a field. Okay, and then maybe I'll put some comments in here. Setters for both X and Y fields. And you know, because they kind of go in pairs, we don't need to write one and check it. We can write them both. So I'll just copy that. You could write one first, then the next one. We also don't necessarily need space between them. Notice errors all over the place because it's all right to have two methods with the same name, but they would have to have different parameters. And that's overwriting. So you might have a setter that always sets it to 0, for example. Seems kind of pointless, but you could do that. We're not going to do that. We're going to have even our default initial point of 0, 0 is just to show you that you can do this. This is not the kind of object that we might need a 0, 0 point as a default, but it's just to kind of show us that we can do it. Instead, we'll do set Y and this dot Y. I want it to come in as an integer here, and we'll set it equal to Y. So then we'll go back to our client. Again, you know, sometimes clients get too long and you want to you can delete or just comment out things that you've already checked. When I'm asking you to submit a client, usually there's a client that goes on while you're writing the code, and then there's another client that's actually using the classes later that exemplifies that the code works. So, you know, there's sort of two forms of clients that we're going to be using. One is for your own personal knowledge to test whether what you're writing is working. And then there's a second client that usually, for our purposes in class, that will have certain requirements where I'm requesting you to do certain things in that client. Usually you just have two. This one is like a temporary client. It's not going to, like here, this is a testing client. Maybe I should put that up in the comments. Point client being used to test as we build point class. And, you know, I should probably not fall out of the habit of putting my name in here. Your name, computer science, 142, the date. These are just good things to be in the habit of doing. And, you know, you could see me automatically fall out of the habit of it just that quickly. Okay. So we wanted to test the setters now. So we have a point P. So I could say, okay, P.setX. Notice the methods are showing up here for me. Let's set X equal to 18 and P.setY. And let's set that equal to 20 or negative 20. And then let's copy the print statements out. So I can just paste them in here and I'll just continue. And you can see right away, the more testing you do, the longer this client gets. And at some point, you might want to either start a new client or just comment things out. But for our purposes here, I'm going to keep the client just so you can see it progressing. So, you know, we might want to put an empty print line statement here. And so after the first point, and another one here after the second point, and then maybe after this one as well. So there's some spacing in between my output. Sometimes makes it easier to look at. You don't just want a bunch of numbers down the page, because that is not, you know, sometimes it'll test, but like it's not an effective way all around to do the testing. You really want your testing to indicate what you're testing. So in the first one, we're testing that X and Y are working. The second one, we're testing the default constructor is working. The third one is testing that our setters work. Okay. Now we want a translate method. So we want that translate method to move the point a distance dx in the x direction and a distance of dy in the y direction. So we'll go back to our point class. And again, I've kind of set this up so my getters are grouped, my setters are grouped. I'll come down below this and I'll define public. It's not returning anything. Void. It's a translate function. And it's taking in a dx as integers and a dy as integers. And I should probably comment above it what it does. So this moves the point dx in the x direction and dy in the y direction. Okay, so how do we do that? So if I'm not using x itself anywhere, I could just say x here. X equals x plus dx. And notice the x that I type here is referencing the x up here in the field of the point. So the only time I have to use the this is if I have two values that are named with the same name. Like here, I have x coming in as a parameter, but I want to access the parent x. So, you know, what's the best way to do this? I don't know. Notice if I do this dot y equals this dot y plus dy, it also references the y value. You know, I don't know what the best way to do it is. We want to understand that both are okay. To me, it looks like the first one is looking easier, but notice if I do change it to this dot x, it's a little more consistent. And what I could do instead of having to type it twice is that I can just say plus equals dx. So that says take this dot x and increase it by dx. And I can do the same thing with the y. Take this dot y and increase it by dy. And again, in this code, I don't need the keyword this here if I don't want it. Notice it still is going to work. And so it's really a matter of choice. Since this is a pretty short method, it's not doing much of anything, I would just leave it like that. If I was doing a longer method, then I might put the keywords back in this dot x plus equals dx. Mainly because at some point you could imagine that it was changing and you want to keep the consistency. I mean, this still is consistent because the reason we're using the this dot y here is because y is coming in as a parameter there. Here, we don't have x and y as parameters. We have dx and dy. So it's really how we've named the parameters that's allowing us just to use x and y here. Okay, so we'll leave it like that, and then we need to go to our client and test that it's working. So let's take this point at 18, -20. Let's take that point, and let's move it. So we can do p dot translate. Notice it's pulling up the method for me. And let's move it 2 to the right, so that should be at 20 there. And let's move it down 5. So it should be, the new point should be at 20, 25. And again, I need to copy this code out. You can kind of see why you might want, we're going to want a toString method that just prints the point for us, rather than having to, copy and print 3 lines of code to do that, or at least 2 lines of code. And it moved it 2 to the right and down 5. So that worked. So testing it, and again, you can already see it's like, okay, we might, after a while, we forget what we did in each of these tests. So at some point, you can just delete them. If it's working, you don't need to keep the code. But I'm keeping it so that we can kind of keep track of what we're doing. Okay, so we just did translate. Let's do the toString method. So the toString method, every object should have one. It returns a string that's usually a nice printout of the object. So, for example, an array would return the array inside the hard brackets. These are going to return a point inside parentheses. So, parenthesis 18, 20, unparenthesis. Sometimes that's specified how you want it. Sometimes it's up to the coder to figure out how they want to do it. Okay. So that's going back to our point client, and I'm just going to keep going down. I want to say the toString methods could be last. I don't know why I feel that, but I think I'm going to leave it as my last method. So the next ones I put the equals and the distance from, I'm going to put above the toString method. I'm not sure if that's just me, a preference for me, or if it's just overall a suggestion somewhere. I'll have to look it up. So public string toString, and there's no parameters. And we basically want to just return a string here. So we're going to return, let's just sort of make sure that it's set up appropriately, a string. So now it's set up. I don't really need to comment the toString method because it's universal. The toString method is returning the string that represents the object. So here, what do we want that to look like? We want to have an open parenthesis. Followed by X, followed by a comma and a space, followed by Y. Notice I don't have to use the this because the X and the Y, I'm only using them once here, so that will refer back up to the global instances, and then add onto that the closed parenthesis, oops, in quotes, closed parenthesis, and a new line character, so that it will return to the next line. I can put a comment in here. Returns a string representation of the point. You could say, in the form parenthesis X comma Y, or I could just go like this, quote, parenthesis X comma space Y, like that. So that shows the person what that's supposed to look like. I mean, you don't really need to do that because it usually will be clear from context. Okay, so we'll go back to our client. So now I can test that here by just getting rid of these. And, oh, yeah, sure. Put a print line statement in here that says p.toString. That'll be the middle one. So it's going to get rid of that 18. Oh, I don't want that. I guess I don't want that backslash. That's a /n. Oops. I don't know if you've caught me at this yet. I don't think I've done it all quarter. They look the same to me. a backslash and a forward slash, something in my brain just registers them as generally the same. There it is, 18, -20. I don't know that we need a new line character as part of that string. That feels a little redundant. So because the string really is not with a new line character, it would just be the thing by itself, and you would put it in a print line statement like I have. And then if I need another line after that, I would put a print line statement after it. Yeah, I don't think the toString method should not have a new line character at the end. So I will put a print line after it. If I can figure out where it is, there it is. And again, just empty print line statement, don't need quotes or anything. Run it again. There it is. So, you know, I could replace, if I wanted to, all of my print statements with this, and then notice it doesn't have the x equals and the y equals. Well, that could be part of your toString method. You could have a toString method that produces an output that says x equals this, y equals that. Generally, you try to have it clear from context, and this is pretty clear to me that what the point is. So you wouldn't really need an x equals and a y equals when it's in that point notation. So for example, we could do this with the second point as well. Just copy that line of code and just replace it in here and run it. Good. Okay, I'm going to pause the video. We'll come back and do the last two equals and distance from. And then my goal is to create a line object that has two fields, each of which are a point. So that object will then depend on this object that we've just created. So, and then we'll need a line client as well. And we'll have a similar set of fields, constructors, getters, setters. Maybe what else would we do with a line? Find the slope. We would check if two lines are equal. Two lines are parallel, perpendicular, is vertical line, is horizontal line. We could have methods like that. So we'll do that next. Oh, after we do equals and distance from.